Hello, welcome to Knowledge of Physics. In this video, I will be showing you how to calculate gravity due to the moon and compare the gravity of moon with the gravity of Earth. So let's get it started. First of all, on the screen you can see this is Earth and this is moon, and this shows the distance between the Earth and moon is 3x4400 kilometer. First of all, let me tell you something about gravity. Gravity due to any planet on a body is the effect of gravitational force per unit mass that results change in velocity of the body. Gravity is nothing but the gravitational force between two bodies per unit mass that results change in velocity of the body. Change in velocity per unit time is the acceleration, so it is also called acceleration due to gravity. Gravity is also called acceleration due to gravity. Gravity due to Earth is equal to 9.80665 meter per second square. This value suggests that velocity of body freely falling towards the Earth surface increases by 9.80665 per meter per second per second. So this value suggests that there is a 9.8066 meter increase in speed per unit time when the body is falling towards the Earth, freely falling. And freely falling body means the body is falling without the effect of any other agents or forces except the gravity. Now let me tell you about something about moon. As you know, the moon is only the natural satellite of the Earth, and the moon revolves around Earth in fixed path, and the path of moon is called orbit. Orbit is the path of the moon through which the moon revolves or moves around the Earth. Moon also rotates around its axis of rotation. So moon also rotates with itself, just as Earth rotates in its axis, resulting day and night. So the rotation of Earth around its axis results day and night on Earth. In the same way, moon also rotates in its axis. Revolving around the Earth, it also revolves around the sun once in a year on Earth. This means this is Earth and this is moon. This Earth revolves, suppose there is sun, okay, and this Earth revolves around this sun once a year. That means during the period of 365 days, Earth rotates or revolves around the sun once, and in the same time the moon also revolves around the sun with Earth. Let me show you some picture of moon. This is the picture of the moon, and it is obviously spherical in shape, and the distance between this north pole and the south pole is called its polar diameter, and this is center. Similarly, the unlike this diameter, the diameter along the equator is called equatorial diameter. You can see here, this is center of the moon. The polar diameter is the distance between two poles of moon, north pole and south pole. Polar radius of moon is the distance between center of moon to either of its poles. Polar radius means the distance between the center of the moon and either of these two poles. This north pole or south pole. Distance between this or this is called polar radius. This is the value, half of this diameter. So polarity is denoted by Rp is given by dp, which is polar diameter divided by 2. Whereas equatorial diameter is the distance along equator of moon. Actually, this is nothing but the equatorial line of moon, and the line along this equatorial line is called equatorial diameter. that divides moon into two halves, that is northern hemisphere and southern hemisphere. I have already told you moon is spherical in shape just as earth, and almost spherical, not exactly, uh, and this equatorial diameter divides the sphere of the moon into two halves, and this is the northern hemisphere and this is southern hemisphere. Half of a hemisphere is half of a sphere is hemisphere. And equatorial radius is given. Polar radius of moon is the distance between moon to either of its pole. Okay, this is the equatorial radius. Re is equal to d by r2. Sorry, Re is equal to d by 2. This is equatorial radius of the moon. Okay, equatorial radius means the distance between this center point to either of these two poles. Now the mathematical expression for acceleration due to gravity, g is equal to gm by r square. Small g is equal to capital G times m by r square. I have already uploaded video of why the acceleration due to gravity at the center of earth is 0. You can watch that video as well by clicking on that I button, or the video link is given in the description. You can also watch that video. In this equation right now, g is universal gravitational constant, and this capital M is mass of the moon, and this r is average radius of moon. And we have, as I have already told you, universal gravitational constant g is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. And for moon, mass of moon is this much, that is 0.07346 into 10 to the power 24 kg. You can see these values on Wikipedia. Yeah, you can search it on Google and just click on the link of Wikipedia. You can find these values there. Equatorial polar radius RP is given by this kilometer, and equatorial radius is this. Okay, and the average radius of moon is the average of these two values, and this average radius becomes 1732.05 kilometer. Average radius is denoted by r here. Now acceleration due to gravity of moon is gm is equal to capital G capital M divided by r square, and inserting the value of g, m and this capital R, we have this this type of expression, and further simplifying this expression we get this type of expression here. This value is squared. Okay, so here is m square, and similarly I have multiplied this and this, which becomes this one 0.499782, and I have subtracted minus this 11 from this 24, and it becomes 13. After that, I by index rule I put here. Okay, this value is missing here. Okay, here is this value, and I have moved this value to the here. So 10 to the power 13 minus 6, and m square is cancelled out, and there is remaining n kg per kg, and the lower this value is as it is there. Now gm is equal to this value is here. I have subtracted 6 from 13, and it becomes 7, and after dividing this value from this, okay, it becomes this, and this multiplied by 10 to the power minus 7, and this 10 to the power 7 is as it is here, and it units Newton means kg meter per second square, so I have converted Newton into its fundamental units, kg meter and second. So after that kg and kg, these two is cancelled out, and we have left with m meter per second square. Okay, so gm is equal to actually this minus 7 is cancelled out, 10 to the power 0 remains there, and that is 1, and the value of gm becomes 1.63326 meter per second square. This is the acceleration due to gravity of the moon. This value suggests that the body falling on the moon surface changes its velocity as 1.63326 meter per second per second, that is rate of change of velocity of body due to gravitation of the moon is 1.63326 meter per second square. This is the gravity due to the moon. Comparing this value with gravity due to earth, the acceleration due to gravity of earth g is equal to, I have already told you, this much, and it has been proved that practically gravity of earth is 6 times that of moon. You can see in any textbook of physics related to moon and earth, this statement, gravitation of earth is 6 times that of moon, or gravitation of moon is 1/6 of earth. That is, gravity of earth is g is equal to 6 times gravity of moon, and multiplying this 1.63326 by 6, we get this value. Gravity of earth is GEC is equal to 9.79956, and this value is almost equal to this. This equation shows that the gravity due to earth is 6 times the gravity of its moon. So obviously earth is larger in mass than moon, so obviously its gravity must be greater than that of the moon. So you can see comparatively the gravity due to earth is 6 times that of moon. Example, here you can see a question: if a person has a weight of 500 Newton on earth, how much does he weigh on moon? If the actually whatever you see on the weight measuring machine or instrument, that is not weight, that is actually mass. So that's why I am writing here, I am showing here mass of weight of the person. So it is 500 Newton. And how much does he weigh on moon? So solution: weight of person on earth is this much, and weight of person on earth, actually the relation of weight and mass is this. Okay, mass times gravity is weight. So mass of person on earth is weight divided by gravity, that is 500 Newton by 9.8008065 meter per second square, that gives 50.98581 kg. So actually his mass is 50.898581 kg. The weight measuring machine shows this value, actually not this, because you have I think you have checked the units there and it shows the kg. So this is the mass, not weight actually. If mass is multiplied by gravity, then it becomes weight. Mass remains same on both earth and moon. So mass is actually independent of gravitational effect. So the mass of the person remains same on earth and moon. So weight of person on moon is this mass times gravity of moon. So substituting the value of mass and gravity of moon, it gives 83.27308 Newton. N means Newton here. This shows that same person on earth is heavier than E waves on moon. So since the gravity of earth is 6 times greater than that of moon, the person of same mass waves heavier on earth than on moon. This is because the gravity of earth is greater than that of the moon. So in this way you can calculate the gravity of moon and you can compare with that of earth. Similarly, you can calculate the gravity of sun as well, if you know the mass of the sun and radius of sun. So here I have considered radius because the object, actually this value is the gravitational effect of earth on, gravitational effect of moon on the body, which is placed just at the surface, on the surface of moon. So that's why I have taken here the radius of moon. Okay, this means the distance between the surface of moon to its center. So this is the gravity due to moon at its surface. this much in this video. Thank you so much for your time. We will see you in next video. Till then, subscribe the channel and hit that bell icon so that whenever we upload a new video, you get the notification first. Thank you so much.